Yeah. Today we are going to discuss about Delta VFD and PLC modbus communication system. Okay. For that, I have taken our Delta PLC. Okay. This is our Delta PLC. Okay. And Delta drive itself. Okay. Now let's start our communications. First of all. Yeah. First of all, before going to enter into the communications and all, first we need to know about the communication. Communication means what? Okay. Let's say, for example, communication. Okay. Communication is nothing but between the PLC and VFD, it is certain kinds between two. When both are matched, then only it is going to communicate over. Otherwise, it won't communicate over. Okay, that's why each and every PLC is having certain modbus protocol relevant register memories, and then even the VFD is also having their own registered memories. Okay, everything we need to analyze it and then move on to the practical kind of here. Okay, and first of all, first point, first I'm going to first we need to go for the VFD here. For that purpose, here I have taken a Delta L series drive. Okay, Delta. This is Delta L series drive. Okay, Delta. This is L series drive action. Okay, for that purpose, here it is 1 HP drive and then 1 HP motor here. Okay, first of all, we need to enter the details of the communication. Let's say, for example, here in the Delta PLC, 2-00 is for the source of frequency command. That means everything, the frequency should come, frequency controlling should come from the drive communications only, drive and PLC communication only. That's why we need to select 2-00 in 2-00. We need to select, we have to select RS485 communication interface. That means go to 2-00 and then enter the 4 value. Enter 4. Why? Because the 4 will represent the RS485 communication interfaces. Okay. Like that, the same thing 2-01 is there. Okay. 2-01 is for the source of operating command. Let's say if you want to operate from the PLC itself directly, then we need to enter the value here 4-1. Fourth one is by RS485 communication keypad stop disable. That means everything should be by the PLC memories itself only. That is the meaning of that. By RS485 communication interface only. Okay. After this is the common communication between the PLC and HMI. We need why? Because we use the here RS485 communications. Okay, this is RS485 communications. Okay, through that we are going to interface with the PLC itself. Okay, that's the reason why first of all we need to enter the details. Enter that details has we need to run the communication here itself by the RS485 communication only. That we need to enter first of all. Okay, after that go for the modbus communications. Go to the modbus communications. For that modbus communications, the parameters are okay. The parameters are 9-00. 9-00 is the communication address. Let's say, for example, I'm using one drive here. That's the reason why I'm going to give the address in the 9-00 as 1 itself. In that, we need to give the 1 itself. If you are using one more drive, like we need to take the 2 itself. If you have one more drive, 3, and so on, 247 drives, we can connect to the our PLC itself. Okay. Next, I'm going to enter the transmitting speed. That means baud rate. Okay. In that 9001, I'm going to enter the detail of 9.6 thousand. The cable baud rate is here 9600. That means 9.6 kb per second. It's a transmitting rate. That's some people is also call it as a baud rate also. Okay. And then coming to the 9-02. It's a default, it will be the 0. Why? Because while you running, it should be run. That is the meaning of this 0 here. Okay. Next 9-03 modbus communication watchdog timer. It means it doesn't need to any type of timing over there to communicate on the. If you want to communicate, you can change here the time. No need here. Why? Because immediately it should respond. That's the reason I'm going to enter here 0 itself. Okay. Coming to the communication protocol also, we have two type of communication protocol systems are there. One is ASCII mode and then RTU mode itself. Okay, ASCII code and then RTU mode itself. Okay. In that cases, we are going to do with the ASCII mode here. The ASCII mode will tell you about the what type of bits we are going to use. Here we are going to use the 8 bits itself. That means A7, 7E, E is nothing but here even parity. 1 is nothing but data type. The parity should be here 1, even itself. 7E, 1 we are going to select. 7 represents the bits, E represents the parity, 1 represents the data. Bit enable. Data bit enable systems. 7E1. Okay. E means even parity. Even parity systems. That means in the 9-04, you should enter the value as 1. First of all, communication address 1, transmitting rate or speed is 1. 9-02, that is the transmitting fault treatment as 0. And then modbus communication timer should be disabled. 9-04 communication protocol should be 1. Everything we need to enter it. Okay, I'm going to stop the screen here. Okay, and I can show you how we need to enter the value of the drive itself. Okay, 1 second. It's visible, right? Here, this is the entry button. This is the back. This is entry. We have to go for the entry, and whatever written we have the screen share is there, right? 2-00. In that we need to enter the value as 4. That means through RS485 communication we need to enter it. Next 2-01. In that we need to also select the D4 itself. This is the back. Just go to the communication mode bus protocol systems. Okay. In that 9-9-00. In that we need to enter the this just remember this one. Why? Because this address we need to give in the program itself. 9-00 is for the communication address. In that we need to select D1 itself. Next, if you want one more address is nothing but okay, I'm taking 1. If you have one more drive is nothing but D2 like that we need to take. Next 9-01. 1 we need to take. Okay. Next 9-02. 9-02 also same. We need to take it as a 0 itself. 9-03 should be timing should be 0. Next parity. This is very important. We should select here D1 itself. Okay. D1 itself. Like that we need to enter the details of the communication relevant. Whatever the communication here we are using the communication. I will explain how we have given this wiring and all also. This is RS485 we are going to give it to the PLC itself. For the PLC we are going to give it to the communication protocol as RS485 relevant. Okay, we need to connect the cable to the PLC itself. In that PLC also we have COM2 is there. COM2 is there. COM4 is available, right? COM2, 3, COM1 is available. In that case, I'm going to use here. This is the communication element. Plus minus are there, right? In that plus minus, plus is for the VC plus and then VC minus. Okay, plus we need to give to the plus of the drive, minus we need to give to the minus of the drive itself. Okay, I'm going to use the communication cable here to communicate with the personal computer kinds. Okay, PLC and drive communication. Now we are going to see, okay, the programming, how we need to enter into the, this is how we need to first of all enter the parameters, then come for the communication wiring. Okay, in the next slide, I'm going to show the communication wiring itself. Next, I'm going to show for the programming itself. Okay, this is the communication cable what we use for the drive communications. Okay, next I'm going to go for the communication wiring and then programming itself. One second. Okay, next next section, next slide is second one. In this RS485, this is the drive relevant. Okay, drive relevant we have the 1, 2, 3, 4, 5, 6, and so on 8 is that, right? From left to 2, that means from first to 8 it is. Okay, in that we need to connect with the 4 and 5. 4 and 5. 5 is plus, right? We need to give it to the COM2 plus itself. Minus is there, na? XG minus, that is fourth one. Fourth one we need to connect to the minus of the PLC component. Okay. This is the plus, we need to connect to the plus, minus is to minus mode, that's it. That we need to check the communication ports itself, whether it is suitable exactly where it is exactly what it is. Okay, everything we need to select first of all. From left to it's like right to left it will go. Okay, in that fourth one is the minus, fifth one is the plus. We need to connect with the PLC itself. Okay, next is this one more. Okay, how we need to, okay, whatever we have that is there. Okay, but we need to communicate the drive on PLC itself, right? Okay, to communicate it we need to use the values into the hexadecimal conversions, then only these two are going to communicate over. We need to do the address of the drive first. We need to analyze the drive parameters first, drive hexadecimal value first of all. Okay, after that go to the PLC relevant programming. Okay, first of all we have given here, we have given the data length B0 to B7. 8 bits are there, right? B0, 1, 2, 3, and so on. 8 bit will be there. Okay, in that first bit will represent here. If you observe the red lines here, first one will represents the data length. Data length, how much we enter? 7 bits, right? That we need to enter here. 0, 7 bit is nothing but see here. 7 bit we entered right here. 7 E1, right? 7 is not much, 7 bit. That we need to select here. 7 bit. Second one will show about the parity. What type of parity we have taken? Parity we have taken here, even parity. The even parity value is here. Even parity bit value is 11. 11 we need to enter. Next, 0. It is the stop bit. Stop bit. Stop bit is please 0 itself. Why? Because in starting we're not going to run it, right? It should be in the stop mode. That's the reason stop bit we need to select here. Okay. In that next one, next 4 represents the baud rate. What baud rate we have taken here? The baud rate we have taken here. How much? 9600. 9600 value conversion bit is here. 9600. Each and everything is having their own value here. Baud rate, their own have baud rate values. These are all. Each and every baud rate is having certain hexadecimal values. Let's say, for example, 110 is having 0001. Okay, 0010, 001. These are all the combinations of the 4 bits. 0001, 0010, 0011, 0100, 0101. These are all the baud rates itself. What we selected here is the matter. What we selected here, 9600 we have selected. The 9600 hexadecimal value is the 1000. That means 1000. It's 1000 we need to enter. Okay. First four is having one value. Next four is having one value. First four is having the value has 0110, right? 011 value, how much it is? 86 it is. 6 it is. Next four values are 8. That means how it is came is nothing but 0, 2 power 0, 2 power 1, 2 power 2, 2 power 4. 2 power 1 value, how much? 2. 2 power 2 value? 4. 2 plus 4, sixth value will come. 6 value is here 6. Okay. Next one. 1000. 2 power 0, 1, 2, 3. 2 power 3 value how much? 8. 86. Okay. The drive value here, hexadecimal value is 86. 86. That 86, H86, we need to enter into the program itself. H86, we need to enter into the program itself. How? How I can explain here? Okay. Coming to the programming of the PLC. This is how the conversions of the drive is saying that okay, I am taking the 7 bits, I am taking the parity as even, I'm going to have the stop bit is that one. At this table, I'm going to encourage. Drive is saying that I'm going to encourage this stop bits, I'm going to encourage the parity bits, I'm going to encourage this data length, I'm going to encourage the baud rate that much. That value is H86 series. Okay. At the same time, PLC will having certain things, right? Okay. The COM2 is having certain bits. COM2 is having a fixed value, fixed D value. That means word value, fixed the word value it have. Okay. That coming to the drive communication programming. First of all, we need to take the M1000 itself. M1000 is nothing but it's a common bit. Every PLC to take the enables and all. Always it is in non-position. That's why everyone will take the M1000 itself. Okay. And the next H86. This is the only communication one. This drive to PLC communication program only. Drive to PLC communication program. It's not a write and read. These are all things. First of all, we need to sync it. We need to sync the drive and the PLC, right? How it is going to sync with each other is nothing but here. First one will represent move H86 to D1120. H86 is nothing but this one drive value. Drive value. This drive value will have to store in certain value, right? Okay. It will saying that okay, both should communicate is nothing but PLC also needs certain things, right? They okay. Drive is saying that this communication cable is coming to you. To the PLC it is saying. Okay. PLC is saying that here. Okay, you are saying okay, but I need to receive this in the COM2 or COM3. We have connected to the COM2 itself. The COM2 value is D1120. If you are connecting COM3, the value is D1109 itself. Okay, and whatever the communication here we are going to explain, that is common for all Delta drive and PLC communication itself. Okay, we need to move the value of H86 into the D1120 itself. Okay, next this D1120 is having their own special memories also, right? That special memory is set 11M1120. Okay, whatever the communications it is, it should be set up. It should be a certain communication format, right? Who will take the responsibility of that communication is nothing but this bit will take the responsibility. M1120 will take the responsibility of the baud rate communications itself. Okay, and then next, whatever the timings are there, right? It should be repeated cycle itself. Who will maintain is nothing but D1129 is going to maintain that. Whatever the communication timings and all. That's the reason why move whatever the 1100 value we are going to move into the D1129. D1121 will represent the time for the detection of the difference be maintain certain timeout settings here. That automatically it will take. I'm going to give the certain value kind of thing here. K100 it is. Okay. Next, what is the RST M1140, sir? Is that is nothing but this particularly M1143 is for the RTU communication, but we have taken ASCII codes. We have taken here ASCII codes. That's the reason we need to reset it. This will represent the RTU relevant. That's why we need to reset it. We need to turn off it first of all. Okay, then only it is going to communicate over there, right? Same thing. This all are going to represent the drive to PLC communications only. Okay, understood up to this point. Next case. Okay, first of all, drive should give or PLC should give first a certain request to the drive itself. PLC should give certain request to the drive. Please give me certain values, whatever you have inside, either the speed or on off communication, everything. That request we need to send it. Okay, what type of request here? I am going to take here M0, M0, M1, M2 are the request methods to the PLC itself, which okay, drives also need to take certain things, right? That is set here. M11122. All the requests will come to M1122. That means this is the drive relevant memory here. It is going to enable it first of all. Okay. If it is going to enable this, we need to enable this M0, M1, M2, right? For M0, I'm taking the on off communication. I'm going to take one counter here. Okay, the special memory here it is M1127. I'm taking. Okay, this is the program will start here. M1127. Okay, again here it is setting. Okay, again you are going to reset it. Set and reset is nothing but pulse will generate over there. Okay, when on off is nothing but automatically count is going to increase over there. Like that same thing, count is going to increase for the other bit like M1129 also. Okay, we are sending okay, which is going to return the value here is nothing but it is going to return the value. 1140 is for the return value. 1140 for the return value of this counters itself. Okay. These are all counters. I am going to comparison with the M06. When both are equal, then only M0 going to enable. When both are 1, then M1 will enable. Both are C0 value and P0 value equal to K2, then M2 will run. Okay, when C0 is going to enable, again reset. That means it's kind of request we are going to give to the PLC. That means on off request is we need to give it to the drive itself. So the drive will take that whatever the request and all, it is going to give certain value to. We need to send a requesting to the VFD itself. What type of request is nothing but these are all the on off request is something speed request and everything. When it is only enabled, then only you are going to get your values itself. Okay. Now for modbus communication program not started. It is just the sending a request to the VFD. Please give me certain things to me, certain values to me. That request it is saying, it is sending. Okay. After this sending under all requesting and all, the drive is going to generating. That it comes to here. Modbus read and write values. Okay, read and write is nothing but what type of drive is having now that values you are going to read in your program that will comes under the read itself. Okay, whatever the value inside of the drive that will comes under the read relevant. Write is nothing whatever you are writing you are going to change that will comes under the write mode itself. Okay, say for example M0, M1, M2 we have send a request, right? M0 what it will represent? M0 is going to take the responsibility of the on of H2000. How I can say that H2000 in that say for example M0 we have taken, right? MOD is mod, WR is nothing but write. WR is nothing but write. K1 is nothing but in starting I told, right? 9000 in that we need to take the first one. If you have drive 1, then we need to take K1. If you have one more drive, K2. That K1 also you should enter the value in the drive itself. That represents the first one. H2000. What H2000 will represent? If you open the manual of the drive, H2000. This is H2000 value. In H2000 value, if you are giving the 10, if you are giving H2000 10 value, then your drive is going to run. If you are giving 01 value, then drive is going to stop there. Okay. Next next M1 will represent the H2001. H2001 will going to represent the frequency. H2000 will 2001 will represent the frequency command. We need to give that frequency command through HMI or through SCADA, whatever kind of it is. Okay, that value we should give it to the in the D11. In D11 you should give it. Okay, like that the same thing. This all are the right address. Whatever you have, you are going to enter into that. Okay, whatever my H2000 is there, na H2000 also same thing. We should write a program for it. Even in the HMI or through HMI also we can run it. There is no need of any wiring between the PLC and drive. Even if you observe our drive also, we don't have any type of inputs and outputs here. See, I will show it here. Okay, these are all drives, right? Drive inputs and outputs wiring. I am not taking any type of input and outputs. I have not taken any type of inputs and outputs here. Only the drive communication itself only. Okay, this is the only. Okay, only the communication is there here. Okay, understood, right? Next, if you want to reset it as well, you can take the 2002 also. That I am not taking considered here. I'm going to consider only on off and speed setups. In the HMI speed setup, how we are going to take it. Okay, M0. If M0 has enabled, then mod WR will go into enable. Then H2000 is going to enable. If you enter the value of 10 in the D10, it is going to run. Otherwise, no. We need to enter the frequency also. Okay. These are all there. Okay. But what about these? These are all points. Mod read. Mod read. These mod reads are whatever the value of the drive itself. Let's say you have entered certain value. Whatever the value here, it is going to represent. It is going to read it here. And it is going to store in the 1050. Okay. One is the sending, one is the receiving. Both are available here. Okay, 2102 is for the receiving, 2103 for the sending. Both read only, sending and receiving both are there. Okay, whatever the frequency value is going to store in the value of M1050. This we need to represent in the HMI itself. Okay, I'm going to move this value into the D20 like that. Okay, now we're going to go to the practical communication itself. 1 second, I can arrange it here. I have written already the programming and all. Okay, and I'm going to communicate it. Okay, this is the whatever the program and all. Okay, view. I'm going to represent down it. 1 second. This alarm. This is a drive request. This is sending. This is communication relevant. This is sending request relevant. These are all modbus communication relevance. Okay, like that. 1051 1051. Okay, clear, right? Yeah. Now I'm going to communicate it. 1 second. It's coming. Is it visible? Is it chief? Just lot control. 1 second. కొంచెం అటు ఇటు అన్నాను. Yeah. Hello then. Okay. Now I'm going to do the communication of this. Compile. First, we can read the values. 1 second. here. First of all, I'm going to say, I have given already the program. I'm going to first of all take the setup and backup of this PLC to PC. Okay, it have already. Okay, view I'm going to represent 50%. Okay, now I'm going to the online itself. See here in the video, prompt is going to enabling. Okay, I get the same thing. Value of H2000 D11. D11 change. I'm going to change here. Otherwise, you can change in the HMIs. I will show how the HMI we need to change it also. K2000 I'm doing. Okay, K2000 and then D10. D10 is for the on off, right? Right. K10 we need to give. When you give it to the K10, once again. Once again. Okay. If I give to the K10, then drive is going to running out here. K10 it's running, right. If I giving here 01, it is going to stop. Okay. Closely, if you observe in this 1050, will going to represent the 2000. Whatever the value I have given, that is going to 1050 itself. You can give any value. Okay. You can give any value in the D11 also. D11, if you're giving 3000, that means 30 hedges, right? If you go to the drive, 30 has given. If I change the value here, if I change the value here, K2000, 20 has changed, right? If you're changing any 1000, 10 hedges, okay, if you then otherwise 1500, okay, 15,000 it is 1500, right? Okay, 4000, 40 hedges, 40 hedges. If you give any value 30 hedges, okay, speed is going to vary, and parallelly this is also going to vary. This is how the PLC drive and then motor is going to communicate through this programming itself. Clear? Now I can communicate with the HMI itself. 1 second, I can communicate with the HMI here. Now I'm going to stop it. Okay. Stop it. Means 01. Okay. After that, first of all, HMI is also connected here. We need to communicate the HMI also. 1 second. We need to bring the communication table of this one. whatever the value we are changing manually, right? That we need to enter through the HMI itself. So that how we are going to communicate the HMI and then PLC and VFD, everything I can explain here itself. I'm going to take the communication cable. I was opening the software of HMI, DOP soft, DOP soft. DOP soft. 1 second. Now open the Delta software, Delta HMI software, DOP soft. Here we use the DOP 13103 B2 HMI model. Okay. And coming to the PLC programming, I have taken here M3 and M4. M3, while I press the M3 in the HMI, okay, the value 1 will move to the D10. 1 is represents the here, 1 is represents the off case. Next same thing M4 is there. If I press the M4, K10 will move to the D10. K10 is represents the run, K1 represents the off cases. Okay, and I'm going to take this D11 also. D11 in the HMI software itself. Okay, and then I'm going to take the D1050. 1050 will give you the speed how much we have in the drive. That I can take here, and then D11 also I'm taking here. Okay, first of all, M3, M4, M3, and then M4. For M3, I'm going to take a button has maintained button. I'm going to give the value here M3. M3 I'm giving, enter, and then in the text also I'm going to take it is for the off case. Okay, M3, same thing for the on case, on. For on, how much it is? M4. M4. Okay, and the text is here on case. Okay, same thing for the numerical entry. Numerical entry. For numerical entry in the PLC, what we have for numerical entry value? D11 is there to enter the speed of the motion. Okay, I'm going to enter it. D11, I'm going to enter into the numerical entry. D11. D11 I'm giving. Simply. Okay. In text, we don't have any text here. Okay, right? Then this one. Okay. Next, numerical display. This is numerical display. Which we need numerical display? The numerical display will show in the 1050. Okay, D1050. Then enter. I'm going to take the text also here. This is speed. Where is the text? speed, display not text, we need text here, speed, speed, running value. Okay, next speed, set value, okay, these two I'm going to download these are all program into the HMI. Okay, if you observe the screen now, whether the screen in front of me is having the same thing, running value and then set values. Okay, next I'm going to reconnecting the PLC communications, whatever the communication cable between PLC and HMI cable we need to put on it. 1 second. Okay, I'm going to communicate it here to connecting the PLC HMI and then the cables. I'm going to stop the screen share. Okay, HMI, PLC and drive. In HMI we have on button. When I press the on button, yeah, like that if you enter the value of the HMI relevant, okay, when you press this one, what we have given here, M3 we have given, right? In program, we have M3 I have given for the M3 I have given for the on for off purpose. M4 in HMI software M4 I have given for the on case. Why? Because when M4 is on, the value will move, K10 will move to the D10. When you turn on the M3, K1 will move to the D10. Okay, it's a numerical display. For numerical display, I'm using one D0105 10 D010. This is the numerical display 1050. Okay, then it is going to display order. I get same thing D11 I'm going to do. Whatever the value here to enter it. If you change the value here, then the value will change in the drive itself. Okay. Tomorrow we can continue our unlock classes, delta unlock communications, how it is going to vary. While vary the temperature, how the speed is going to vary. Everything I can explain in the on the next class. Thank you.